Okay guys, welcome back. So in the last two videos I explained to you about resistors in series and resistors in parallel. So what actually happened was that when resistors was in series, the current was constant, so that the current flowing through all these resistors was constant, and the voltage was divided among the resistors, right? The total voltage was equal to the individual voltages as represented for the resistors. And when the resistors were in parallel, what actually happened was that the total voltage was equal and the total current was divided individually among the resistors. Alright, so this is the simplest summary I can summarize those two videos. So in this video I'll be talking about how the voltage is divided, how the voltage can be divided when two resistors are given and a voltage is given, and how the voltage actually is divided among the resistors. So we have to discuss the topic of potential divider. So welcome to the topic of potential divider. Potential divider, right? Potential divider. Alright, so potential divider is a simple apparatus like this, right? A simple apparatus in which one resistor is constructed this way, R1, and another resistor is constructed this way, R2, and the voltages between these 2 points, I'll take it as V, and we have to find the voltages between these 2 points. I'll take it as V1. So what is V1? So that is the question I'm asking you. So what is V1? Alright, so what actually happens is that if I send a current through this circuit, I, the current will flow through this circuit here and here, right? So what you can say is that you can say from Ohm's law, V equals IR, So you can say V is actually equal to I times R1 plus I times R2, right? I times R1 plus I times R2. So V equals, you can take I out of this as a factor, R1 plus R2. So I is equal to V by R1 plus R2. So why I calculated this way was that in order to find the voltage across this, resistor, you need to know what is the current flowing through this resistor. Now we have been given the voltage of V, we have been given the values of R1 and R2, but we have not been given the value of either the value of I. You have not been given the value of I, and we have to find the value of V1. So in order to find the value of V1, we need to know what is the current that is flowing through R2. So the current that is flowing through R2 is actually the current, because these two resistors are in series. The current that is flowing through R2 is equal to the current that is flowing through the whole circuit. So that I explained in this videos on resistors in series. If you have not watched that video, I invite you to watch that and come back here, because it will be of utmost importance, because it will be the concept basis on this video. Alright. So since you found the value of the current that is flowing through the circuit, so you can, for R2, you can say for R2 V equals IR, you can put Ohm's law, right? So the voltage across R2, I'll take it as V1 is equal to I times its resistance R2. So we found the value of I, we can substitute that here. So V1 is equal to I is equal to V by R1 plus R2 times R2. So V1 is equal to VR2 divided by R1 plus R2. So what actually happens is that now the potential divider divides the voltage between these two circuits. Alright, so that is the concept of potential divider. So I'll take a simple example. In which I'll take a simple example. So the question says like this: a load of 2000 ohms, right? A load of 2000 ohms is connected via a potential divider of resistance 4000 ohms to a 10 volt supply. What is the potential difference across the load when the slider is 1/4 and halfway up the divider? So the question, the figure has been given like this. So the figure has been given like this. So this is a sample question, right? One of the popular questions on potential dividers are taken. So the apparatus is like this. So this will be this, right? Like this. So this is a resistor, right? And we have been given a 10 volt supply, 10 volt supply, and they are saying that the total resistance of this resistor is 4000 ohms, and we have been connected another resistor like this, 2000 ohms of 2000 ohms, one at 1/4 of this, and one at halfway up the divider. So if this is at 1/4, so if this is the instance in which the resistor is connected at 1/4, so since the total resistance across this is 4000 ohms, the resistance across this should be 1000 ohms, and resistance above this should be 3000 ohms, right? So what it is asking is, what is the potential difference across the load when the slider is 1/4 and halfway up the slider? Alright. So this is the slider. This is the slider. You can slide this. You can slide this. Right? You can slide this upwards, downwards, anywhere. Right? So if at 1/4, you have to find the effective resistance of this circuit and then find the voltage. Voltage across what is it? What is the potential difference across the load, right? Across the load when the slider is 1/4 and out. So what they are asking is that what is the voltage? What is the voltage across this one? What is this voltage when the slider is first 1/4 and second halfway? Alright. So when I am taking 1/4, I will take it as 1/4. When it is at 1/4, you can say, you can deduce a relationship that these two points act as these 1000 ohm part and the 2000 ohm part act as two resistors in series, in parallel. So you can put V equals IR for a parallel relationship. So I divided by we can say 1 upon R first, right? 1 upon R effective is equal to 1 upon R1 plus 1 upon R2, right? So 1 upon R effective is equal to 1 upon R1, which is 1 upon 2000, and this is 1 upon 1000. So the total, this one will be 2003, 3 upon 2000, 1 upon R effective. So R effective will be 2000 by 3, right? 2000 by 3, and the unit is ohms, right? 2000 by 3. So we have been asked what is the voltage across this, right? The voltage across this when it is halfway and when it is 1/4. So what actually happens is that if the resistance, equal resistance between this resistor and this resistor is 2000 by 3, what is the effective resistance for the whole circuit? What is the effective resistance for the whole circuit is that, now this is very similar to this situation. This is 3000 ohms and this is 2000 by 3 ohms, and this is connected to a 10 volt supply. Is connected to a 10 volt supply. So we have to find the value of I here. So what actually happens is that the total effective resistance will be total effective R effective T. So we found the total effective resistance between these two resistors. This actually a single resistor, but we divided according to the potential divider. That is the importance of potential divider. We divided this resistor into two parts using this slide. Actually, we didn't physically divide. We actually imaginary divide, right? Imaginary divide these two into two parts. Into one part of 1000 ohms and the second part is 3000 ohms. So what actually happens was that we found the effective resistance of these two resistors. So in order to find the effective resistance of the whole circuit, we have to take the effective resistance of these two resistors, which is 3000 ohms. We found here it was given, and the effective resistance of these two resistors, which is 2000 by 3 ohms. So now these two resistors are in series, so the effective resistance between these two resistors is actually the summation of these two. So that will be 3000 plus 2000 by 3. So that will be 11,000 by 3 ohms, right? 11,000 by 3 ohms. So the effective resistance is 11,000 by 3 ohms. So we have to find the current that is flowing through this, right? So what actually happens, you can find the current and then find the voltage, but what I will do is I will use the concept of the potential divider. So using the concept of potential divider, you can say V1 is equal to V times R2 by R1 plus R2. So what actually happens is that the potential difference across this resistor, I take it as V, is equal to the voltage. Now what actually happens is that the potential difference across this resistor R2 is equal, we found, is equal to the total voltage of this circuit times the ratio of the resistances. Alright. So the ratio of these resistances, now it will be like this. So this is 10 volts. So this is 1/4. So this is 2000 ohms. This is 1000 ohms. And this is 3000 ohms. And I took this voltage to be V, right? Took this voltage to be V. We had find V. What actually happens is that from this equation, V is equal to the total voltage across this circuit, which is 10 times R2. R2 is the resistance across what we are calculating, right? Resistance across the voltage we are calculating. So that is actually equal to 2000 by 3. We found that 2000 by 3 divided by R1 plus R2 is the total resistance of this circuit. So we found that to be 11,000 by 3. 11,000 by 3. So this will solve to here will be, we can cancel this. So this will be 20 by 11. So this is 111 upon 9. So this will be approximately 1.8 volts. Approximately 1.8 volts. So that is 1/4 way. So when it is halfway, what actually happens is that it is very simple to this one, very similar to this one, this apparatus. So this will be halfway now. So this is 2000 ohms, and the total resistance across this circuit is 4000 ohms. So this part will be now, and also this part will be also 2000 ohms, and this part which is resting above this will also be 2000 ohms. Now these two resistors are parallel. So what actually happens is that the effective resistance of these two will be 1000, right? It will be 1000. So this is analogous to this part. This is 2000 ohms. This is 1000 ohms, and this is 10 volts. You have to find the voltage across this. Right? We have to find the voltage across this. Alright, so the voltage from the potential divider theorem, voltage V across this is equal to the total voltage which is then times the resistance across the point we are taking, which is 1000, divided by the total resistance of this circuit is 4000, right? So this will be 1/4, right? 1/4. So that will be 2.4 volts. So that will be 2.4 volts. So these are two examples. So these are two examples of the potential divider. I used a simple example and a very popular example that is used to explain the potential divider theorem. Alright, so this is the importance of potential divider. So if you are given that two resistors are connected in series, you can find, if you were given the total voltage of this setup, you can find the individual voltages of the resistors. So that is the importance of potential divider. So I will meet with you with another concept on current electricity with the next video. See you then.